Hello everybody, my name is Bhavishya and in this lecture we'll see the metric for OSPF. And we saw in the series when we were talking about routing information protocol, the metric for it was hop count. Right, now when we talk about the metric, what does we mean? So the definition of metric says it's a way to measure something, to compare options and choose the better one, right? And in networking, routers also need metric to measure and find which path is better, right? Let's see the example of our routing information protocol. Okay, as you can see here, let's suppose the rep is working throughout this topology. Now, in order to find the best path, we use hop count, right? Let's suppose it wants to reach from PC1, it wants to reach to our PC2. From 10 network, we want to reach 20 network, right? So our unit is hop count, right? So if we take this way from this particular, from R1 to R2 to R3, from R1 to R2 to R3 to R4, not R4, but yeah, R3. This is where we reach the network. It takes 3 hop count. It is 3 hop away, right? This is the first part. The second part is when I go from R1 to R5, then R4. Right, that is my 2 hop away from R1 to R5. It is my 2 hop away. So which is best option here? The best option is the second one because the lesser the hop count, the lesser the hop equals to better path or best path. Best path to distance. But this was incorrect in a larger framework because we are only seeing the metric in rep as hop count. But let's suppose they are using fast ethernets here, and here we are using giganets. And as you know, the speed of the giganets is 1000 Mbps. So this is going to be fast, right? And this is going to be slow. So this is the reason why in OSPF the metric is cost. Now what is this cost? To calculate this cost, now to calculate this cost, we use bandwidth for the calculation of it. If you look at the formula OSPF cost, the formula is we take a reference bandwidth now divided by our actual or interface bandwidth. So what is our reference bandwidth? So let's understand what is the interface, what are the types of interface that we use and what is the bandwidth of it. So the interface that we use, interface and then bandwidth. The interface is our Ethernet. The bandwidth for the Ethernet is our 10 Mbps, Mbps, right? Then we have fast Ethernet, our fast Ethernet. The speed of the fast Ethernet is 100 Mbps. Then we have our gigabits, gigabit Ethernet, gigabit Ethernet. The speed of the gigabit Ethernet is 1000 Mbps. Then we have 10 giganet, 10 gigabit Ethernet. The speed of it is our 10,000 Mbps, right? Yes. Now the question is, and also the use case is, Ethernet we rarely use this. Fast Ethernet we somewhere use this. When we talk about when we talk about our gigabit Ethernet and 10 gigabit Ethernet, this is what we use in our enterprises, right? And everyone is 10x to each other speed wise. Now, as we know the formula, now when we use, let's suppose for Ethernet, so the bandwidth is our 10 Mbps and the cost is, my reference is 100, right? And then interface, that is 10. So the answer for this will be 10. Let's suppose you're talking about the fast Ethernet. The answer will be 100 divided by 100, that is equals to R1, right? Now when the reference is 100, because when OSPF was developed, we only had two interfaces, Ethernet and fast Ethernet. Now let us take an example and see how it is getting calculated. Now here in this case, our router 6 wants to reach to this PC3, or you can say 30.0.0. network. So what is the cost for this? As you can see, we are using Ethernets in between the interface 1, 2, 3. So the formula says the reference bandwidth divided by the interface bandwidth, right? So the reference bandwidth is 100 and the interface is 10, so that gives us the cost 10 for 1. As we have 3 in between 1, 2, 3, so the cost, and yeah, let's suppose, by the way, 10, 10 and 30, right? But let's suppose instead of Ethernet we have this as fast Ethernet, then the cost will be 10 plus 10 plus 10 plus 1, that is my 21 cost for PC3, right? Now let me take a different example. Now in this case we have, instead of Ethernets we have fast Ethernet all over. So the cost will be, as the reference bandwidth is 100 divided by 100, answer is 1 for each, 1 plus 1 plus 1, that is going to be my cost as 3. And what if I ask from router 7 how much the cost will be? So the cost will be 2, right? Now we have different interfaces too, the faster ones like gigabit and Ethernet. So what happened in that case is, in other cases like giga and 10 giga, as we have called the reference as 10, it goes in round off to our 1, right? For both of them. So to differentiate between the faster speed, it becomes a little difficult, right? So what we will do is we will adjust the reference bandwidth to our 10,000 from 100. For that, the command is we'll go to router OSPF. Let's suppose router ID is 10. We'll use the command auto. After auto, we'll say cost, and then the reference bandwidth. Reference, and then bandwidth to be 10,000. Right? This is how we'll do it. Now the cost for these will be, copy this. After this, the cost will be, as this has 1 to 10,000. Now this will be 100, 10,000. For okay, this is 1,000. For this, it will be 100. For this, it will be 10. And for our 10 giga, the speed will be 1. Right. Now let's take an example where we are using gigabits in fast Ethernet and all along. Now here, let's suppose PC1 wants to reach to 20 network or PC2. So the cost for this will be, if you look at the upper end from R1, R2, R3 and R4, as the reference bit is 1000. So for the very first one, as you can see, gigabit, that will give us, as it is giga 10, but before that we have fast Ethernet. So 100 plus 10 giga, that is at 3 times 10. So all total it will give us 130 cost for this upper route. But let's suppose we took the lower one, this lower path. So our cost will be 100 due to this. After that we have fast Ethernet, that will be 100. Then this is also fast Ethernet, 100. So the total cost will be 300. So by this we will use the upper one, that is giving us 130. So OSPF choose bandwidth because of that reduces the congested networks, right? And this is what we pay for, high speed and all, right? So this was it for this lecture. I hope you enjoyed. See you in the next one.